Hello everybody and welcome to the stream. If you haven't already, please toss me a follow at Travis the Maker on Instagram and also on Twitter. Usernames are linked right there. Cool. So, today we are going to do some updates on the 2D plotter, some 3D printed parts and things like that, and then we're going to jump over into building some new things. So, let's hit up Instagram for our updates. So, had oh, I thought I posted a photo. Guess I didn't. All right, we'll close out of that. So, basically, what happened was one of the parts snapped, and that was a whoops. So, 3D printed some different ones, looked into sorry, having a brain fart here. 3D printed some new ones, added some extra material. So when you 3D print, you can choose kind of the thickness of the walls and how many layers of plastic make up the walls, because the inside is actually usually hollow. And so I increased that, printed some new parts, and put them kind of a stress test. Kind of bent my 2D plotter frame around. Things are looking good, so that's cool. What else in the updates? So yeah, just covered all those things. So today on the to-do, we are about to the point where we want to start writing things in code, really. And so we are going to learn how to use Python to control the Arduino. So we're going to send commands over a USB cable, this USB cable right here, and send those to the Arduino. And then hopefully the Arduino will receive those. So I did some research off stream, and I found this link to an article, which we're going to use as inspiration. Hey Cheez-It, welcome to the stream. And basically it walks through, yeah, a little Arduino sketch and then some Python, and so we're going to use that as an example and kind of learn how to do things, and then we're going to walk forward, kind of get it to work with what we have in mind. So our goals for today are to get it to move to a position, so send a command that says move to this position in the 2D plotter, and get it to home itself, so basically go back to 0, 0 if you think about like an XY axis. So we're going to learn the basics first, and then we're going to take a quick break and wire up our switches, which will be needed to do the homing, and then we will try and set up our commands. So those are the goals for tonight. Hopefully we can get through all of them. I'm super excited to learn how to use Python to control Arduino, so we will jump in right now. Cool. So let's see what the code says. All right. This is a lot as an example. Holy moly. Okay, let's read through what this guy wrote. Thought it may be useful to produce a slightly simpler version of the Python Arduino example, which only uses printable characters. That means that the Arduino program can be worked from the serial monitor as well as within the Python program. The new version also contains elements of the code from this thread to illustrate how to parse the data and use it to control LEDs in the servo. The Arduino code assumes that there are LEDs connected to pins 13, 12, and 13, and a servo to pin 8. If you send this command to the Arduino, it will set the flash interval for LED 1 to 200 milliseconds and will move the servo 50% of its range. Okay. don't know what RB means. Let's see. Ruby. I thought he just said Python. Okay. Maybe we don't care about that. I think we want the... Discard that. We'll open this with Visual Studio. Okay. Just curious if there's... This example seems a bit kind of, excuse me, overkill for our goals. Also, these posts are from like 6 years ago. All right. So I think first step is we're just gonna. Also, for those in chat, I'm doing a little bit of experimental displays tonight, so bear with me. So we got this display, which you should see Arduino in the bottom left corner, or the bottom right corner, with VS Code and some video. So if I turn on the webcam, hopefully we will see my hands. Not quite. Pop. Which little button? Cool. All right. So, first step, I want to just hook up the Arduino to the computer. Running out of ports on my Arduino, so we'll plug that in there. We will move this out of the way. Cool. Plug this into the Arduino. Perfect. All right, so I think our goal will be to try and get the built-in LED to turn on or off based on code that we send. So if we get rid of all of this and just do, actually, scroll to the top. Okay. So we need our setup and our loop. Cool. And let's see, if we type, so serial.begin, that's basically just a way we do communication in Arduino. You'll see it come to life in a second. So we say hello, and then we delay. Delay is a function that takes in a number of milliseconds. We'll wait half a second. So we initialize the tool that communicates via serial, and we can monitor that from the computer. And then we can type the message hello, and then delay for half a second, and then just it'll keep repeating itself because this is a loop, and it'll go forever. So you guys can't see the drop-down menus I'm selecting, but basically I'm clicking on Tools at the top, going to Board, selecting Arduino, going to the port, hopefully clicking what I think is actually the Arduino port. Looks like the Arduino is blinking, so the sketch is actually there. Let's see. I wonder if you guys can actually see this screen. No. Okay. So we'll switch back to desktop mode, and we'll see the message. So this is actually, the code is on the Arduino, and it's sending this code back. So next up, we want to receive, how to receive message. So we want to send a message to the Arduino over serial, and once we can do that in Arduino code, we'll then move that over to Python code. Here we go. Wait. Let's not go for a help bit. So let's look at the Arduino reference. So serial.write value, no. Kind of confused. I thought I could, oh, I can click on only reference. All right. So serial, write binary data to the serial port. No, not kind. How about read? Serial.read string reads characters from the serial buffer into a string. The function terminates. Okay. Is there an example? Oh man. Okay. So this example code receives data and then prints out what it received. So let's see what this does. All right, so we've typed letter A. We should expect to see it in the terminal as response. I receive. Okay, so, sorry, my wires are all tangled. Give me one moment. Okay, cool. So I think, okay, 10 is enter. So if I just hit enter, it's 10. Character 97 is A. So that reads incoming bytes. So that's an example of serial.available. So I think read string is what we want. Change that to string, and we change incoming byte to incoming message. What am I doing? Okay. So let's see. Can I just print this out? I'm totally winging it. I have no idea what I'm doing. But that's how we learn, you know? All right, so we're done uploading. Chances I can just type in ABC and it'll come back. I didn't think it was going to be that easy. Okay, so like DEF. Cool. Okay, so I think this is everything I need to communicate to the Arduino. So now I need to learn Python. All right, so let's see what this file has to say. So the purpose of this program and the associated Arduino program is to demonstrate a system for sending and receiving data. The key functions are send Arduino and receive from Arduino. read these notes if we need to. Okay, no idea what just happened. It's the run test. Does it fail silently? Hold on, let's change things from here. Change some things here, sorry. Okay. Wait, this is not correct. Okay, now we're in the Windows subsystem Linux. Cool, so okay, now it's kind of confused why it didn't complain before. This all feels like Python 2 code. Alright, so let's real quick. I thought he said he converted to Python 3. Oh, okay, let's download this code instead. Let's run it again. Alright, what do we got? Could not open port. Okay. Okay, open device manager. Click on view, show hidden devices. Locate ports. Common LTP in the list. So let's see, we chose port COM11. I have zero idea what I'm doing right now. Let's see if I can go to that path that he had mentioned. He had mentioned it's dev tty. So cd here. Sorry, I got an itchy nose tonight. Cd dev. Okay. Okay. Don't know what this does. Let's run it. Returns nothing. Okay, let's see what this code does. So there are available ports. Let's actually make a Alright, so make a little file check ports.py because I like whatever this thing does. If we run it again, those three, I don't know how to tell which one's actually the Arduino. What? Oh, okay. So I think it's the 11 means it's Arduino. Python. Okay, so we take that code again. Change it to this. Here. I have no idea what's happening. Okay, so we opened. What does this code say? Wait for Arduino. What does that do? Wait until Arduino sends Arduino ready. Allow. Okay, interesting. So. Okay. Looks like I can't upload while I'm connected to it via Python. It's interesting. Okay, done uploading. Let's check the Arduino sketch. Just want to pop this into VS Code. Okay. Oh, okay. That's what I want to send it. So, if we print this, upload that. Oh, come on. Ugh. Can't open. Wait, COM3. We're on COM11. Okay. Wait. Oh my gosh. Is that all it took? So can I just come in here and go like, no, wrong file. Right here. No, here. So I say hello world, and then we do, actually I don't know the full parameters for serial.print. What if we do this? Okay. Whoop, I should cancel this. It is already canceled. All right, so what I'm expecting is that I'm going to send hello world, and I'm going to get hello world plus we back. Oh gosh, I got to enable autosave. I'm not used to not having it. Okay. No reply. This is not how you concatenate strings in C++. Is it a plus? It is a, yeah. So I did. Okay. Was this the issue? Okay. If we run this again, so what does run test do? Send from PC the string hello world. Okay, let's work our way backwards because I might have messed something up. Okay, so it seems like it's sending messages back. Send to Arduino. So it doesn't seem to be doing anything interesting. Interesting. Does it have something to do with him putting angle brackets in? Or her? Yes, totally is. Interesting. Okay. So running tests. so confused why I can't send things without angle brackets. Oh, okay. Here we go. Where are these defined? There they are. Okay. I think these are Unicode characters. So if I go down to character 60, I bet you, yeah, you see HTML code 60. And then I bet you this is 62. Yeah, it's 62. So the message starts with the left angle bracket, ends with the right angle bracket. Okay. Can work within the constraints of that for now. All right, so let's rename this to test and actually take the code from this and kind of strip it down to what we need it to be. All right, so we don't need any of the comments in here. Does he include his name or anything? Nope. I want to say thanks to whoever this is. We got Robin2. 66,000 posts. Wow. Helpful guy. Holy moly, everyone here has a lot of posts. 17,000? Does he have like a Twitter? I don't know how to thank this person. I'm not going to randomly Google that username because I don't know what's going to happen there. But anyway, okay. So delete all this. Delete these quotes. Why are these declared outside? I don't like that. Let's move these up. And let's delete this line. Okay. Okay, that's any value that is not an end or start marker. So ord of z, oops, it's 122. Ord of a is 97. Oh, that's kind of confusing. Okay. So x can be like the character received. I think ord of empty space is something. It's not. All right, we'll make it the blank space. You can't ord none, can you? No. Okay. So this will keep looping until we receive the start marker, which is the word of, this is our start marker, which is 60. So you can see that there. And then ser is, we're going to move this up to the top. I don't like imports. Not at the top of the code. Okay. Don't need these prints. We will get this and look at the number to match the COM port in the Arduino software. So 9600 is kind of the communication rate, which is what we put in there. So that's fine. I don't like ser. It feels like a bad variable name. So we don't want to call it serial. Let's call it Arduino. That actually kind of makes sense. Cool. So this can actually be taken down here, and if we set up a main function, so we want to copy this all there. Cool. Okay, so for each message, so we want to rename this function called like send message. Okay. The casing is not Pythonic, so we're going to make everything cased as such. I don't quite follow this logic. Don't think we need it. Let's sleep for 1 second instead of 5. Don't need this anymore. Okay, so we can actually delete this. And we're going to put this into main. So we'll send to Arduino. We'll leave that there for now. And then data received from the Arduino, we'll print the data out. We don't need this time.sleep. And then we will close the connection with the Arduino. Okay. Arduino is not defined. Whoops, I might have deleted too much. Ah. Local variable x. Cool. Just whacking moles here. N is not defined. Line 70. Let's just go there. That is true. Cool. Okay, so now if we send hello and then we send back Alright, let's see if this will do what I'm hoping it will do. Because it'll send any message to the Arduino, but it will only read out and print messages that have these angle brackets. No? Okay. I'm kind of confused why it didn't actually. It should send. Oh, okay, I see. If we do this. No. It's getting hung up somewhere in the code. Alright, what if we just So it's just working. Okay, this is where we stopped adding things. Right there. So I feel like it's getting maybe stuck in here. Maybe it does not like this code. Oh, wait. Okay, so it gets here, prints out the baud rate, and okay. So after that happens, it runs the main function, it gets stuck in waiting for Arduino, which I'm guessing it got stuck here. Maybe not. Oh, I bet you get stuck right here. Yes, okay. Arduino dot in waiting. It's still there. TTY S11. Does it just not like this? There's a lot here I'm kind of new to, so, but we don't want to run that again. Okay, that program's stuck. That's fine. Okay. Okay, so the thing we are stuck on is in waiting. I'm confused how I even ended up with okay, things weird here. problem. Great. All right. While this goes, I will be right back. All right. Cool. Cool. Okay. Okay, whatever. There we go. Okay. pip3 install serial. Okay. So I bet you if I run this now, it's going to fail because of deprecated things. Yes, great. Okay. Okay, so port equals dev 11. Baud rate 600. Okay. 32, line 46, line 37. Okay, I think might have deleted a line. No? Okay, Arduino is ready is what we want to see. Int object is not callable. Get the number of bytes in the buffer. Great, I did something dumb. We just comment these lines out and see what happens. Okay. Gosh. I don't want to start over, but I might have to. This is also getting stuck now. Okay, and what was this script? Let's just drag this in here. I could have swore, sorry. Serial.print. Oh, is it because I didn't print line? And also because I removed the angle brackets. Nope, don't want to do that. Whoopity whoops, 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 whoops. Okay, yep. Okay, so this ran in object. So in waiting, I believe, is now just a cool. All right. So let's try this one more time. So if we send Arduino something without brackets, and then let's just sanity check. Can we just send back? Cool. Moment of truth. Can we modify the incoming message and send it back? Sweet. Yikes, that was confusing. Okay. We should probably commit this. We want this. So let's call it what we called it before. We called it Python to Arduino. So we want to make a Python file. Okay, so we can finish cleaning this up. Let's call this message. Okay. I think this will mostly serve as an example for sending messages. Cool. And then we want to save this alongside that. Cool. Nope. Wrong place. Oops. Alright, we are not going to display this on the screen, so we're just going to hit a little be right back. Okay, cool. So we got that code committed. Sweet. Cool. Sorry, I just got to check on something real quick. All right. Cool. So, project logs. For today, we learned how to do this. We hooked up, or that's what we learned. Okay, so we learned the bare minimum. Now we're going to hook up some physical switches. So we are going to switch over to the pure video only. Not that one. Not that one. Okay. Let's troubleshoot this real quick. I'm just doing some technical things on my end. Chat, if you have any questions, feel free to shoot them out. Cool. So, boom, boom, boom. Okay. So we're going to flip on, put our soldering iron in the back. So if you'll remember, this piece sits like this, and we want these holes right here to have this little switch. So, oh, we don't want to turn the soldering iron on. Whoops. I need to change the bits out, and it's going to be real hot. Okay. That's okay. That's okay. Grab the trusty Leatherman. Let's zoom out for you guys. Cool. That gives you a little bit more room. So, okay. Put this hot bit down there. Let's rest this back for now because I need to figure out which of these bits I want. So for those who don't know, these bits are very cool. You can basically use a soldering iron and press them in to plastic parts. Okay, cool. So, cool. Okay, now we can turn the soldering iron on. I know that last time we bumped it up to 550. So we'll do that. Basically what we're going to do is we're going to press each of these in right there, and then we'll be able to screw in our switch. Cool. Alright, so the soldering iron is heated up. So these tips that I've ordered for the soldering iron are actually not, are too big for what I'm trying to press in. So this might be slightly difficult. Okay, that's not that bad. Cool. First one in. Next one up. Wow, that was surprisingly easy. Cool. All right. So now we're going to grab out some screws, some M2s. Ooh. We'll need 2. Cool. And this should sit just like this. And we will grab some Allen keys to screw it in. Turn off the soldering iron because we don't need that anymore. Cool. Just trying to match up the holes here. Cool. Apologies, I'm kind of looking right into my fan as I lean over. Okay, cool. Perfect. Nice. that is pretty slick. Ah, man, this thing is slowly starting to come together. I'm excited. Cool. All right, so let's use these alligator clips that I just purchased. Cool, so we're just going to need a black and a red. And let's get the rest of this stuff out of the way. Alright, so what our goal here to do is, first up will be the easier thing. We will try and get it so that we can send, actually this won't be that hard, a command that will cause the motor to spin clockwise, counterclockwise, and that'll be kind of move it. This eventually will be attached to a belt. So let's actually bring up a photo real quick. So let's switch back over to the desktop. One moment. Okay, so this is the motor. This one up in the middle is the one we're talking about today. And so this is going to have a belt that runs across over to here. And we basically that'll be like the X direction, we could say. And we want to get it so just as we send a command that makes the motor kind of move left and right and keeps track of where it is. So that'll be the first thing, and then we'll set up a home command that'll make it go back to 0, which will basically be triggered by the motor will keep spinning until the switch that we just attached is tapped, and then the motor will stop. So let's do that. I really don't know enough about Python, or sorry, not Python, C++, unfortunately, so it's going to be a little bit difficult, but we'll do our best. So basically, let's go to VS Code real quick and kind of type out what we want to do. So we want to say like step 1 in Python, send command 0. Actually, at this point, it doesn't really matter. So the commands will be of the format X, Y, and Z, or X, Y, and Z, where X and Y are the position that the motors. So this first motor will control the X, the second motor will control the Y, and then the Z will be whether the pen is touching the surface or not. So send a command like that. And then in Arduino, read command X, Y, Z, store in variables. Let's give it values. So 20, 30, 40, where the format is X, Y, Z. All right, so for the time being, we don't care about the Y and Z axes, so we will just focus on move motor to X equals 20. Actually, we can do this all at once. So we will have home the motor to 0, 0, 0, and then we'll move the motor to X equals 20. So this is what we will try to do. So these will be the 3 steps we do in Arduino, and then the first step in Python will be to send those values over. So cool. So we want to have the Arduino just read in the string and then send it back for now, just to make sure that it's still working. So if we run that, we're sending message 20, 30, 40. We received back message 20, 30, 40. Cool. So oh, we don't want Arduino. So maybe we can split on spaces. Oh my gosh. Okay, let's copy this, look at it in VS Code. Okay, so we set up, so we only want, okay, so it gets 4 locations. So the captured string is that. So it will read in strings. Angle, fuel, speed, and altitude. What did it say? Expect a string like 90, low, 5.6, and 125. So if the string is star, okay, so star is the last character. So we don't want star, we want an angle bracket. Okay, so if serial.available, looks like we don't need the greater than 0. So we grab a char. Okay, so let's send this message without spaces. How about that? Okay. So we don't need indice 4. And we won't have these. It'll be X position, Y position, Z position. We don't need to see 4. Okay. Okay, so indice 1. So this will be X position. This will be Y position. Z position. Okay, so what this does is okay, let's simplify this even more. Let's go like that. That more closely matches what they're doing in the example, and then we can modify later. Okay. So, while characters are coming in on serial, if it does not equal the star, we will come in at else, and we will just keep reading the string. Else we will take that read string, and we will print it out, and then we will get the first index, the first comma, the index of that. And the X position will be to read everything from the 0th index of the string up to the first comma. So that'll give us 20. And then it'll repeat for the Y and the Z position. Okay. And then it'll print that all out. Cool. Okay. Does this have a setup? 9600. Okay. Let's go to that thing we don't need. Okay. So hopefully oh, Z position's wrong. Why is it wrong? Substring. Okay, so this gets us the first comma, so we want everything up from 0 to the first comma. Also, this looks like it's off. So I'll put that. Okay, Y is now just blank. Oh, I think it's here where we don't want this. Okay. And then this. For some reason, this is coming out as 0. Why is it coming out as 0? No, it's just nothing. Okay, so the whole string is 20, 30, 40. Okay, interesting. I feel like we're on the right track here, and we'll just stay here. All right, so this all makes sense. I'm very confused why. No, doesn't like that either. Whoops, I should probably upload this. So it can't find the last comma, is what it's telling me here. Which is confusing. Oh, can't do comma separated. Bummer. Okay. Let's see when indice 1 is. Indice 1 is 2. Or 0, 1, 2. Okay. So we are now searching. Sorry, indice 1. Okay, is 2, which makes sense. And then indice 2 should be 0, 1, 2, 3, 4, should be 5. Indice 2 is 5, which makes sense. So we're now searching in the 6th. 0, 1, 2, 3, 4. Oh, okay. That does make sense. This code was set up for four things. I actually deleted perhaps the wrong bit of code. Okay, so we actually want indice 4, which is just to read this is what we want. Okay. So we don't need this. We don't need this. We just need that. Right? Yes. Okay. Debugging for the win. Cool. All right, so now 20, 30, 40 star. Okay, Y position is 1 off. Let's try that again. 20, 30, 40 star. Perfect. I'm a little confused why 50 is on the next line. Whoops. Oh, is it the new line that's left over from the previous? I bet you when I first upload this sketch, it's going to work. 10, 20, 30 star. Yeah, so it's going to capture it. So actually, we don't want new line. If c equals that, and I think we can get rid of the star. Perfect. Love it. Okay. Cool. So now we can just send X, Y, and Z positions from Python. Like so. Okay, I think if we get rid of the new lines, this ln, which will add that /n in at the end, will cause this message to show up in here. So okay, so let's see. So we're going to send 20, 30, 40. We're going to see if we can't just comment out this stuff and this stuff. And maybe just change this to while true. And luckily with Git, we can kind of revert all of this if we need to. And then we'll print the character received. Okay. TT, oh, because we have the serial monitor open, and only one thing can talk to it at once. Okay, so Arduino was initialized. And then send message never got called. Ah, because we deleted the Arduino is ready. Okay, need to close this. Now we can upload. Nope, doesn't like that. What is it failing on? Something here. Oh. There we go. Okay, so, oh, interesting. That's kind of cool. It received each of those characters in. Cool, cool. We are learning stuff here. So to wait for the Arduino, we want to message.find. I don't know. Ready. Ah, and we can see that there's a character So that's how Arduino ends lines, with the /r/n. So what did that have? No, this is C++. Not what we need either. For those that are new to chat, we are trying to use Python to send messages to the Arduino via serial. And I'm in the documentation for PySerial. Read until. That's interesting. How do we use that? Read until an expected sequence /n by default. Okay, so that's it. Okay. So Arduino dot read until rn. Okay, so I think this will print out what if we do that? Does it have to be bytes? Alright, let's change this back to true. Okay, so that worked. Alright, so let's comment this back out. So while character received does not equal I don't think we want end markers anymore. Okay. Can only concatenate. Okay. We have to decode the character received. Okay, cool. Don't need this. Don't need this. so we'll upload our new waiting for. Now it's waiting for the string ready. We should be able to run it now. Cool, so it's ready. Sent message 20, 30, 40. Cool, and then we're sending all this back, which I thought should have... Let's print character received. Okay. So there's ready, and we sent the message. Chances it just gets stuck at hello after. No. Receive from Arduino. So receive from Arduino. So wait for Arduino does return ready. Oh, and then it prints line at the beginning, which is what we were waiting for, which we don't need. We don't need this, we don't need this. Wait, where does read string get defined? Oh, there it gets added, and read string is, oh, it's, okay, it's declared up there. So, we don't need any of this, we don't need that. This is what we want. Okay, cool. No? Oh, right, because I had to upload it. I gotta disconnect on the right side before I can upload. Okay. Progress. No. Okay, now I'm actually confused. So all this should get sent over serial, and we should be seeing that here, but instead we're just seeing a new line. And we're not even seeing any of the received characters. So if we just change this to no. Let's do this. Okay, so that got rid of that new line. Is it somehow getting stuck in here? I'm wondering if if there's a fact that no, we don't see that either. Where is this coming from? So our setup, wait for Arduino, waits for a message ready, which is what comes received from the Arduino. And received from Arduino will not return until it encounters a new line. And it even prints out ready, hits the new line, returns the message, and then the message is printed out here. And then no, because it gets out of here. Because we wait for Arduino. We don't need that. And then we see send to Arduino, which we're sending the message. And it'll keep going until it's, oh, does it get stuck on new line? Do I have to send new line? Okay. There are totally standards and ways to do this. I just have never been there before. I feel like I need to go learn more about bytes and serial communication. Good to know, good to know. All right. This is pretty cool though. Okay. Let's save this, save that, and commit this. Where is this saving to? Okay, I should just open up that file. I don't know what's happening, but it's not showing up in Git, so... Oh, heck. Can I open it over here? There's nothing in there. Arduino. Oh my gosh, can I spell Arduino chat? Dino. No. I don't get the Windows subsystem on Linux. I don't. And I really don't want to learn Windows terminal commands. This is where I sip some beer. Okay. We'll just make it here for now. Cool. Status. What? Okay. Oh. It got deleted? Can I move Arduino chat INO to there? No such file or directory. Do I have to copy? Cannot create regular file. Oh my gosh. Yeah. Windows subsystem Linux. I don't get you. I don't get you. Okay, whatever. It's committed. Okay, cool. So we want to convert the x position to an int. ToInt function allows you to convert a string to an integer. So we receive a number from serial. Cool. Okay. So let's see. Let's do these shouldn't be globals. So this is, let's just declare them here. String. Cool. And red string I think is defined down below. And these should be gone, and this comments can be gone, and this should work exactly the same. Read string was not declared in this scope. Okay, that's true. Shouldn't actually be declared here. It should be declared outside the if. String to int initialization. Oh, did I? This is a string. Okay, if I run that same Python sketch, that should give me the same. Cool. Sort of. Right, okay. We've lost. Hey, hey, hey. Great. Okay, okay. I don't care. I don't care. The sketch is not gonna hopefully be that long. Okay. 20, 30, 40. Cool. All right. So let's set a global X, Y, and Z position. So we need to call these like received. Call them X position instruction. Cool. We don't need this anymore. So these are actually for troubleshooting, so we don't need these. Cool. All right. So what was that function? Int to int. Okay. So we want, for now, we want an int, which is x position. I'm trying to think of how we want to do this. So first we want to home it. No. Let's just make the motor rotate. So we'll say x position is 0. So our first step is we're going to get the motor to spin. So a full rotation of a motor is 200. This isn't the wrong file, this one. Okay. So we are going to declare a stepper motor. Let's just grab an example. Servo stepper. Step 1 revolution. Okay. So we're going to take this code on the left side, throw it on the right. We're going to kind of go line by line. Delete these comments. So we need to include stepper.h. This is the 200 that I was talking about. Initialize the stepper at pins 8, 9, 10, and 11. And so we if I can get my camera to work. Okay, battery's almost dead, unfortunately, so we are just going to real quick connect the pins on this stepper, which is not the most exciting thing. Maybe y'all don't want to see me anymore, so let me, actually, I'm going to bring my camera up above the screen so we can point it downwards. And hopefully y'all will be able to see my desk in front of me. Cool. So bring this up here. I took a photo on my phone of the way that the wires are supposed to be connected, so I'm going to look that up real quick. Alright, so the wiring order is green, gray, red, yellow. Okay, so green. And we're starting at pin 8. Okay, green, gray, red, and yellow. Alright, cool. So first, I'm going to throw a little sticky note on my stepper motor so everyone can see it. Hopefully this doesn't fall off immediately. Okay. And that can rotate fully. So it looks like we can see that on webcam. So we will upload this example sketch, and this should, looks like this code will just spin one time, one full rotation clockwise, and then one full rotation counterclockwise. Okay. Looking good. Looking good. All right. So let's upload my other sketch so the thing stops rotating. Oh no, Y position, okay. Okay, that should upload now. And it should stop rotating. Cool, okay, so we will set up our stepper at a speed of 60, and then inner loop, we will step the X position that comes in. And then that function that we looked up was called toInt. All right. Oh my gosh, if this works, I'm gonna be so excited. All right. Here we go. Here we go. So we are hopefully about to send a rotation, one full rotation to the Arduino. Oh my gosh. So I can just keep doing that, and it's just gonna keep rotating. Oh man, that is cool. That is cool. That is cool. Oh man. Oh, it's these big hurdles. Oh, I'm so excited. These big hurdles like this. Woohoo! Love it. 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 Okay, cool. We can control X commands. We can control X positions. Wow. Okay. So I think the last thing we want to do is we want to set up our on-off switch to make the motor stop spinning. So I think if we just wrote like some excessively large amount here, and then we ran that code, so the motor's just going to keep rotating, but we want it so that we tap here, it stops immediately. And then we will call that a successful stream. All right, we're going to let that keep rotating for a second while I grab some wires that we will need. We're going to need 2 wires. Okay. Doo-doo-doo. All right, bear with me one sec. I'm just grabbing some stuff out of my little bin. Okay. So, it's actually, I just want to set up a thing real quick. If we switch over to webcam only, drop this down. Cool. So, we want to set up alligator clips to our push button. Alright, it looks like the instructions for how to use this little toggle switch are on the other side, which I screwed to the 3D printed part. So let's actually grab another one off the shelf. Okay, cool. So, nope, there aren't actually instructions on the other side. I lied. Alright, let's just wing it. Actually, we could use our multimeter to check this real quick. So, without knocking my shelves off the wall, let's grab my multimeter out. So you guys might not be able to hear this, but actually I believe you can because I checked this last time. We want to make, let's see, let's figure out the connection here. Okay. Let's see. No. Okay, so what we've learned from that is that where the black connector and the red connector are connected, when this is pressed down, we complete the circuit in there. So we want to attach alligator clips to the middle and one closest to me. Cool. And then, so we have little pins so we can actually connect it to our Arduino. Like that, and we'll go pin 13. And then we'll connect the other side to ground. Cool. All right. So I think as a little experiment, we're going to write a little bit of code in Arduino to check if the circuit is completed. We'll turn on the little onboard LED on the Arduino. So we will set pin mode for pin 13 to be input, and we will do digital. Let's look up a little example sketch. What do we got? So in is an input if the value of input is high and input is of type, value is of type int. Okay. We're just going to do that. Actually, we don't want it plugged into pin 13. We want it plugged into pin 12 because pin 13 is actually used for the built-in LED. Okay. Let's see if we did this correct. All right. So I actually have no idea what I'm doing. Okay, so the LED is not actually doing anything either way. So you're reading pin 12. If it is high, I don't think, let's see, I might need one more thing, which means nope. It's just Okay, so it says low. Always says low. Why is that? Oh. Oh, whoops. Okay. I had things plugged in the wrong place. All right. So there is cool. All right. So by default, this pin is low, and then when it's pressed on, it's high. So we'll need to integrate this into our other code. So we'll do int switch equals 12. And then in our setup, we'll do pin mode switch pin input. All right, so we'll need to we're gonna need a way to interrupt. So while cool. And then we'll do all right, so what this is saying is if we receive an instruction that says take the X position and increase it to 200. So this is 200. This is 0. And it will constantly keep reading the switch. And so if at any point, so pretend the switch is always off. So this will just not happen. It'll keep going. It'll step by 1. It'll increase the X current by 1. And then it'll go back again. So keep going 200 times. If at any point the switch is pressed down, so if I press it down now while it's spinning, say it's at 100, and it comes through, switches on, val is high, it'll break out of this while loop and it'll stop spinning. Cool. So let's see if I did that right at all. All right, so we're sending the Python command to start to spin, hit the switch, and it stops. Good stuff. Cool. So what that switch kind of means is that, let's go back to Instagram. So we attach the switch to these pins right here. Actually, this is probably actually easier to see in SolidWorks. While SolidWorks is loading, I will be right back. Okay, sorry, SolidWorks is still loading. So the general idea here is that we want so on boot up or at some point, we basically want. So imagine you're plotting, I should say, and your plotter is like over here, and your plotter shuts off. And then you tell it to start printing again, and the motors actually don't know where you are, and so they start going this way, and they're like hitting the wall here, and like that's not good. Or they're hitting the wall this way, also not good. So on initialization, when you want to start printing something, first step should always be to zero it, send it home. So since you don't actually know the values, you basically just keep sending it this way until it taps this motor here, and then it'll know it's home. Similarly, there's this motor over here, and it'll want to keep going this way until it taps that one to say it's home. And that's basically what we've attached today to this part, is a motor to take it home. Or sorry, is a switch to take it home. So, yeah. Alright, so the stream has been going on for 2.5 hours. I've kind of reached where I want to be. We have laid the foundation for sending commands from Python to the Arduino over serial. And we have a way to home the device, and those are the two commands that I've proven that I need to do a 2D platter. So, yeah. Very, very cool stream. I'm very excited about all this. So if I think back to my to-do list for the stream, it was to get to this point where I could do home and move commands, which I've proven I can do now. So to wrap up, we want to let's close out of all the windows I had open. We want to take this and we want to save this to here. Cool. So that's pushed up. This is done. Don't need that. Close out of all the things. Cool. So that is it for this stream. We're doing a whole ton of preparation for a series of workshops I will be leading. If you would like to, you can check it out at painlessprototyping.com or in the link below. We will be learning a week-long series, or doing a week-long series on CAD code and circuits. Later this week, check the calendar, check back. We will be doing some preparation workshops for that. So I invite you to attend. I also invite you to sign up. It's totally free, no previous experience required. And thanks for watching, and I will see y'all next time.